Hello and welcome. In my last video I went through the theory of how to graph or sketch a polynomial function. So let's do an example in this video and put all that theory into practice. Here I have a polynomial 3x to the power of 4 plus 4x to the power of 3 minus 12x squared is equal to, well, I'm going to call this function f of x. The very first step in the process is to find the y-intercept. And to do that we simply evaluate the function when x is equal to 0, or find f of 0. And it's pretty obvious that we're going to get 3 times 0 plus 4 times 0 minus 12 times 0, and that's going to give us 0. So our y-intercept is equal to 0. Next step is to find the stationary or critical points. And these points are points where the gradient or the slope of the function is equal to 0. So I'm going to find first the f prime of x, or the first derivative of the function, and then find the roots of that equation. So f prime x is going to equal 3 times 4x cubed plus 4 times 3x squared minus 12 times 2x. So we're simply using the power formula to find the derivative, and if I tidy that up we're going to get 12x cubed plus 12x squared minus 24x. And this is the equation that I have to set equal to 0 in order to find the roots. So I'm just going to mark that out in yellow. And if I switch pen colors to make it a little bit more clear. So 12x cubed plus 12x squared minus 24x is equal to 0. I can see that I can factor out a 12x. So if I take out a 12x, I'm going to get inside parentheses x squared plus x minus 2 is equal to 0. And if I divide both sides of the equation by 12, I'm simply going to eliminate the 12 on the left hand side, so I'm going to be left with x outside of x squared plus x minus 2. So I know straight away that one of the roots is x is equal to 0, x is equal to 0, and the other possibility for this equation to hold true is that x squared plus x minus 2 is equal to 0. So I'm going to have to factorize this quadratic expression to find the other two roots. So let's do that. If you need help on how to factorize a quadratic equation, I'm going to include a link in the description box below on how to do that, but I'm just going to go through this quickly without spending too much time on it. So I'm going to write this x squared plus x minus 2 as x squared plus 2x minus x minus 2 is equal to 0. And in the first two terms I can factor out a x. So I'm going to get x outside of x squared plus, not x squared, sorry, x plus 2. And in the final two terms I can factor out a negative 1. I'm not going to write the 1 because I'm lazy. I'm just going to get a negative outside of x plus 2. And that's still equal to 0. And a common factor between these two is this x plus 2, so I'm going to factor that out. So that will leave me with x minus 1, x plus 2 is equal to 0. And again, for this expression to hold true, either x minus 1 is equal to 0 or x plus 2 is equal to 0. So we're going to get the roots of x is equal to 1 or x is equal to minus 2. So our three x coordinates of our critical points are, let me just circle that in blue, x equals 0, x equals 1, and x is equal to negative 2. So that's only half of the step of finding the critical points. The next is to find the y coordinate of the critical points. And so to do that, for our first critical point of x equals 1, sorry, of x equals 0, it's simply a matter of, so my x coordinate is 0, and they're simply evaluating the function at that point. So that's going to give me 0, 0, as we found that f of 0 is equal to 0. For the second critical point of x equals 1, again, that's a matter of evaluating the function at f is equal to 1. So let me write that out. So I'm going to get 1 and then 3 times 1 to the 4th plus 2 times 1 to the power of, sorry, I'm going to get 4 times 1 to the power of 3 minus 2, 12 times 1 squared. And that's going to evaluate to 3 plus 4 is 7, minus 12 is negative 5. And finally, for my third critical point of x equals negative 2, the y coordinate of that is going to be, again, the function evaluated at x equals negative 2, and that's going to give me negative 2 comma 3 times negative 2 to the 4th plus 4 times negative 2 to the 3rd minus 12 times negative 2 squared. So negative 2 to the 4th is 16 times 3 is 48 plus negative 2 to the 3rd is negative 8 times 4 is negative 32, and then negative 2 squared is 4 times 12 is going to give me negative 48. And that's going to evaluate to minus 2, negative 32. Okay, so we've found all of our critical points, and let me circle them in pink because I can't choose any better color. Alright, the third and final step of the process is to determine the nature of each critical point. So, nature of each critical point. And to do that, we first find the second derivative of the function, and then evaluate the second derivative at each critical point. and that's the x. I should say that's the x coordinate of each critical point. And we have three scenarios. One, if f double dash is, or f double prime is less than 0, we have a local max. And the second scenario, if f double dash is greater than 0, we have a local minimum. And finally, if f double dash is equal to 0, we have what's called a inflection point. So in the second step, we determined that the first derivative is equal to 12x cubed plus 12x squared minus 24x. So we just take the derivative of the first derivative to find the second derivative, and that's going to give us 12 times 3x squared plus 12 times 2x minus 24. And what's this going to evaluate to? This, just tidying this up, we're going to get 36x squared plus 24x minus 24. So in our first case, the x coordinate of our critical point is 0. So f double dash at 0 is going to equal 36 times 0 is going to be 0, 24 times 0 is 0, minus 24. And this is less than 0, so therefore at the coordinate of the critical point 0, 0, we have a local max. Secondly, at x is equal to 1, f double prime of 1 is going to equal 36 times 1 squared plus 24 times 1 minus 24, which is equal to, well, 36. And that's greater than 0, so therefore at the critical point of 1 and negative 5, we have a local minimum. And finally, for our third critical point at x is equal to negative 2, f double prime of negative 2 is equal to 36 times negative 2 squared plus 24 times negative 2 minus 24 is equal to 36 times 4 is going to give me, so 6 times 4 is 44, so 6 times 4 is 24, and 3 times 4 is 12, that's going to give me 144, minus 48 minus 24 is going to equal a total of 72. And that is also greater than 0, so therefore at the critical point of negative 2, negative 32, we have a local minimum. If you are currently studying math, please feel free to subscribe to my channel for future videos that may help you on exams or assignments. And as always, please feel free to ask me any question by commenting on any of the videos that you've seen. Thanks for watching, and I hope you've learned something.